Well, good evening, everyone, and welcome to Let's Talk Your Home's Energy Use. My name is Tom Knezovich, and I'm the chairperson for the Nith Valley Eco Boosters. I'm happy to be the host for tonight's event, which is being co-presented by Climate Action Waterloo Region and the Nith Valley Eco Boosters. I would like to thank our supporters for tonight's event, Kindred Credit Union, Future Ground Network, and the Township of Wilmot. So why a webinar on home energy use? Well, there's a number of reasons. The Nith Valley Eco Boosters felt that there are a number of greenhouse gas targets in existence. For example, Canada's target and the region of Waterloo's. And we wanted to help people understand what they could do as individuals to help help Canada and the region of Waterloo meet those targets. So Canada's target is net zero by 2050, and the region of Waterloo is target of reducing emissions by 50% by 2030. So in addition to just those targets that we have, we also wanted to help people understand that one of the biggest ways that you can reduce your greenhouse gas emissions is by taking a look at your homes and the energy use in your homes. And buildings, including homes in Canada, account for 18% of greenhouse gases. And a lot of people are not aware of that. The final reason that we're putting this webinar on tonight is that there are some grants available through the Canada Greener Homes Grant, up to $5,600 per household. We know that not everyone can afford to do retrofits, but at least these grants, although they're not a lot, they do help a little bit. In terms of some of the things I wanted to mention that we will not be discussing tonight or not focusing on, and I just mentioned the Canada Greener Homes Grant. That's probably the last time we'll talk about grants tonight. We could spend a whole webinar just talking about grants and rebates, so we're not going to do that tonight. And the other thing that we will not be doing tonight is we will not be making specific recommendations on specific brand names of products or contractor names. So for example, we won't be saying you should buy this type of window or this brand of heat pump, or you should use this contractor. Those are things that each individual has to do on their own. You have to do a little bit of research and decide which products and which contractors are best for you to deal with. It gives me great pleasure to introduce our keynote speaker for the evening. We're really fortunate to have him with us. Greg Labbe, and since 2017, Greg has been running the laboratory for the Building Science Graduate Program at Toronto Metropolitan, formerly Ryerson University. To stay sharp, he also does contract work testing large buildings for air tightness and leakage. Previously, Greg worked as Director of Retrofit Services at Greensaver in Toronto for 12 years, primarily focused on energy auditing homes and their energy retrofits. During this time, he completed energy audits on over 1,000 homes, and he jokes that he has insulated so many attics that the fiberglass is still in his knees and his elbows. Greg then ran his own consulting firm for 5 years, focusing on high performance homes. He has worked with many engineering firms in building diagnostics, typically with moisture and odor related problems. In addition to Toronto Metropolitan University, Greg has been a building science educator for the Ontario Home Builders Association, Toronto Community Housing Corporation, Humber College, and McMaster University. Greg was a contributor to Home Energy magazine, and his blog was acclaimed Bloggers We Like by Green Building Advisor. He was also one of the Ontario Home Builder Association's Institute of Building Excellence trainers and a Train the Trainer for energy auditors with National Resources Canada. Finally, here are 3 things about Greg that I do not understand. He is a certified level 2 thermographer, a FIAS Plus verifier, and a certified passive house consultant. Since that terminology is terminology that I don't understand, I'm going to turn things over to Greg. I've asked him if he could explain those certifications to us before he begins his presentation. And I'm sure that that'll help us to understand a little bit more about his background. So at this point, I'm going to turn things over to you, Greg, and I'll just stop sharing my screen.
Thank you. Those are very generous words. Thanks for the introduction. Hello, everyone. I hope everyone can hear me. A little sound check. So yeah, I've just recently finished my my FIAS verifier training, which is so FIAS is the North American version of the European Passive House. So I'm going to talk a little bit about it. Just delve into it a bit. It's basically a high performance building standard. You know, really one of the best. It's the top of energy performance when it comes to building high performance buildings and homes. Anyhow, the verifier means that I'm typically a person that would be contracted to come out and test and make sure that the assembly of the building is going to perform according to what was modeled in the energy modeled, and what was also spec'd by the architect. So so that's what that is. And the thermography is you know, it's a tool. I use infrared thermography to diagnose a lot of water issues in buildings, but also air leakage issues. Air leakage is, you know, on par with water leakage. If you have air leakage, eventually you get water which converts to condensation. Condensation, when it gets cold, you know, it just turns into a river of water. So yeah, without further ado, I will just give me a second here. I'll get can everyone see my screen?
Yes, we can, Greg.
Okay, great. All right. Myth Valley Echo Boosters. You know, I should really look on a valley on a map and find out where the Myth Valley is. It sounds pastoral, and it sounds like it's a breath of fresh air. I was downtown Toronto on my bicycle today, and I don't know what it is with the horns. It was like such a beautiful day, and people are honking their horns like crazy. So anyhow, welcome everyone. I look forward to eventually either meeting you in person and or answering questions from you if you have any. I'm sure you will. I hope you will. So yeah, essentially, let me see if I can get the, there we go. So the buildings that, you know, as Tom says, I now work for formerly Ryerson University, which is now the Toronto Metropolitan University. I work in their building science lab. I help master's and PhD students do their research. It's physical research, so it involves making pumps, options, putting in, you know, building stuff, and so, you know, machines, testing equipment, etc. So the types of buildings that I've tested all kinds of, you know, this is a building in Prince Edward County, designed by Solaris Architecture, a little firm here in Toronto. This here is you know, these are all high performance houses. This one here is, you know, it nestled in the Beaver Valley, beautiful home. This one here is down the street from me. It's a retrofit of a vintage home by Solaris Architecture again. This is again, you know, north of Waterloo, and a vintage old, you know, Victorian beautiful house. There was actually a snake in the attic of this house, which shocked me. Anyhow. The things you find out there. So we've tested buildings, all kinds of buildings in London, here in Toronto, Hamilton, high rise, you name it. So I said, as a chemist, I eventually worked for Greensaver, which is part of Green Communities Canada. I then opened up my own consulting firm, and now I work for this new name, the formerly Ryerson. And I hope you're all chuckling. So if you feel that I'm bright, maybe my talk today will dispel any myths. I hope I adequately cover all the topics that you hope I might cover. And if I don't, you can always ask questions at the end. And I consider myself a public servant. And if you have questions in a month from now or 2 months from now, give me a call, write me an email at Ryerson. I'd be more than happy to help you out. So today, what do we want to talk about? Well, what am I going to present to you? I want to talk to you about why saving energy makes sense. I want to talk a little bit about buying energy in Ontario. And I want to talk about your home and how it works. And then we're going to talk about how energy conservation works. And we're going to have the Maslow's hierarchy of needs, a prioritized list of what you should consider upgrading first. And then, you know, as Tom says, I actually won't talk about programs that can help you, but there are programs out there. So just cross number 5 out. So delving right into it. Energy efficiency delivers a number of things. It delivers manageable utility bills. So you should have fewer shocks when there's unexpectedly cold weather, or if you get a month of really, really crazy heat and humidity. It gives you more comfort. It gives you greater building durability, right? The components last longer because they're typically less affected by the heat and moisture, typically more of the moisture flow through them. You get improved indoor air quality as a function. You get improved resiliency. And by resiliency, I mean all of these super high performance houses differ greatly from the house that I'm in. So just to let you know, full disclosure, I live in a house that was built in 1914. It's semi-detached. I've got a double brick wall on this side, and it's double brick the rest around the rest of the house. I live in a house that is there's just a dime a dozen of them. There's probably tens of, certainly, yeah, probably tens of thousands of this style of house, semi-detached brick, double brick, red brick houses in Toronto. So, you know, if we compare my house to these houses, and you know, I'm starting to insulate, but I'm still not yet. Still not done yet. This is a case of the cobbler's shoes here. When we talk about resiliency in a building, number one, if we had some kind of a catastrophe like a flood, and some of you may have experienced floodwaters or seen it in your neighborhoods or areas around you, it certainly is something that increasingly will happen. And if we have a storm that knocks out power, well, these high performance houses will retain their comfort for many days. Whereas my house will typically, you know, think about Texas and the winter storm they had a couple of winters ago in Texas. You know, they have no insulation, so there's zero resiliency. So the power gets knocked out, the temperature in the house plummets, the pipes freeze, and now you have to not only, replace wall insulation and sections of wall flooring, but your pipes, all of your pipes have to be replaced, or the sections that burst. So resiliency is about, you can withstand. You can, in the face of adversity, you can live in your house comfortably. So resiliency is a key part of this. That's one takeaway I want you to really, when you're upgrading your house. Another benefit of energy efficiency is typically you get a quieter home with smaller and simpler mechanical systems. Sorry about the double small there. It's the same, and on top of that, sustainable thing to do. On the smaller thing, Suzanka wrote a book, a series of books, the small house, and she's got a lot of great ideas there if you're thinking of a new house, living with a little bit less. So the breakdown of total energy use in an average Canadian home, this is from a Natural Resources Canada. It's for an average home, okay? It's not, maybe it doesn't apply to you exactly, but this is generally the breakdown. What this means is, like, literally 3/4 of the energy you spend are spent on water heating and space heating and cooling. Okay, so this space conditioning, 3/4 of your energy bill. The rest are, appliances, lighting, and plug loads. So computers, TVs, etc. Switching gears now, your home and how it works. Heat moves in every direction, okay? It moves through the basement floor, it moves out the wall, it moves through the ceiling, through the windows, through the doors. Heat moves through all of these surfaces and out, okay? I'm not talking about air, I'm talking about heat. What is heat? Well, heat moves from more to less. So whenever you have heat, it always wants to go to where it is cooler. It dissipates. So that heat will actively move in from more to less. So if it's cold outside, the heat will move from inside to outside. That's why you have to pay to replace it. Whereas if you're in the middle of winter and or in the middle of summer and you're cold inside, the heat outside is literally wanting to get back in. And it does that primarily through conduction. Okay, so this is conduction here. So everyone has, maybe recently, maybe dinner tonight, you've touched something very hot, you've burned yourself. That's conduction, when you touch something. So conduction involves touching something. So the heat inside the house touches the paint, it gets the paint excited, the paint touches the drywall, it touches the wood frame or the insulation, etc. So it's a conduction thing. Now, if there happens to be an airspace in there, now we're talking about convection. Now the air has got to kind of move around, and it convects the air around and moves the air, again, from more to less, from inside to outside if it's wintertime. And then there's radiation. So if I look at a house that's heated versus the garage, for instance, the garage right next to it that's not heated, with my infrared camera, when I take my infrared camera, I look at the two houses, the garage is the same temperature as the tree next to it, okay? But the house is actually a little bit warmer. I could tell that there's heat inside that building. Now we're going to talk a little bit about air. Air, we heat air in our house, or even if you have a radiant system, ultimately you have heat. You have the air is actually warm inside your house. If you have a forced air system, that's the primary way of heating and distributing air, is we heat the air and then we distribute it throughout the house. And so that hot air pocket, we want to try and keep it inside the house typically. We want to manage it tightly. But there's a lot of forces that act upon a house to dislodge that air. Okay, so if, for instance, be a very windy day, if you live near a lake and the fetch of the lake, the wind just whips across the lake and hits your house on that windward wall, you're going to feel a lot of coldness. But on the leeward side, all the air is being sucked out, so that's usually the warmest part of the house on the leeward side. Whereas when we talk about stack effect's a phenomenon that usually only is most pronounced when there's a big temperature between inside and outside. Yes, in summer times you'll have a different difference in temperature. Maybe it's 35 degrees Celsius outside and you've got your air conditioning on and you're trying to keep it at 21. But that's still, only a 14-degree spread. Whereas if it's wintertime and it's -30 outside and it's plus 20, that's a 50 degrees spread across that building envelope. That's a huge difference. And so you'll get a lot of pronounced stack effect. And typically, this diagram here shows a stack effect happening in wintertime. I know it's wintertime because the hot buoyant air, well, even in summertime, that typically happens, but there's forces that combat it. I'll show you in the next slide. So typically, in a house in wintertime, if it's a tall house, you get a lot more stack effect versus a short house, you don't get as much. So in a tall house, the biggest bang for your buck is to air seal the top half of the house, because that's where all the pressure, like a hot air balloon, is pushing up against the top half of your house. And typically what happens is, you get the cold air that comes in through the bottom of that bottom half of the house. Obviously the basement headers, this little space right down here, you could see the little arrow coming down here and into the house, okay? So the next is combustion and ventilation effects. So if we have an exhaust fan in our kitchen, over our kitchen range, or if we have an exhaust fan in our bathroom, typically when you turn them on, it's a one-way ticket. It goes out of the house. Well, if you suck out a basketball of warm air out of your house, not only did you lose that humidity, but you lost that warm air. And you're not going to create a vacuum in your house. So what happens? Cold air from the outside or warm air, warm humid air in the summertime replaces that volume 1-for-1, okay? So sometimes the mechanical devices we have in a house do affect air leakage adversely. So it's something to take note of. So in the summertime, typically what happens is because we air condition a house, the air tends to be cold. And if you're air conditioning the top half of the house, that cold, dense air falls through the rest of the house, cascades down and gets pushed out to the bottom half. Whereas in the wintertime, again, this phenomenon here with wintertime is much more prevalent in terms of stack effect, what happens in most of our homes, okay? We don't get a lot of this. Maybe if we lived in Georgia or Florida, we'd worry more about this. But either way, when you air seal a house, you get rid of both of these problems, okay? This is a problem with envelopes, building envelopes that are poorly assembled. Okay, so sources of moisture in a house. So they typically include showers, or baths, plants. When we get out of the shower, we have towels. What do we do with those towels? And we cook. If you're making a big pot of tomato soup or a pasta sauce and you're boiling pasta, that's a lot of humidity that you end up putting in the air. Drying clothes could be a substantial amount of humidity. Probably one of the worst ones are foundation leaks and drying firewood indoors. So if you take firewood from outside and it's not really dry, if it was cut down this summer and it's September, October, you want to make a fire, you're putting in a lot of humidity in your house. So yeah, it's good to be mindful of where that humidity comes from. And of course, when we breathe, if it's a really tight, airtight house, we expel quite a bit of humidity. We exude through our skin. We sweat quite a bit as well. So again, this is big picture thinking here. The evolution of high performance building, and I'm not saying that I live in a high performance house or you do or that you want to, but ultimately the goal is to try and make our houses more efficient. And it's always good to have aspirational goals. And so I'm gonna take the high road, and we're gonna talk a little bit about these basic concepts of really high performance house. So right now, when you buy a house or when you build a house, it has to be code compliant. So it has to meet the Ontario Building Code. And what do what do engineers say about the Ontario Building Code? It's the minimum standard before lawsuits become prevalent. So really, code compliant is just, you're just scraping by. Typically, if you have a good builder, they'll give you some options on how to beef things up. Maybe it's a structural thing, maybe it's more insulation, better performing appliances. But even your appliances, everything's prescripted by the Ontario Building Code or the National Building Code if you happen to be have a house outside of the province as well. So really, it's the lowest performing building you can have. Having said that, a new Ontario house performs a hell of a lot better than even the house that I'm in, sadly, right now, which doesn't say much about my house. We started insulating the main floor and the basement, but the top 2 floors, I don't know, something about having kids and a full-time job just takes all the fun out of renovating. Anyhow, the next sort of rung would be Energy Star. So you can get a house Energy Star certified. It involves energy modeling and somebody doing testing on the house. So all the 3 next building types, they're all tested. Okay, that's the difference. When you show up on a construction site, builders know they can't get away with whatever they want. They have to. They're bound by law. They actually have to build a better product. R2000 never really caught on in Southern Ontario, but in Northern Ontario, Ottawa, parts of Quebec, the prairies, the R2000 program is still pretty, fairly active. But down here in Toronto, I don't think I've ever tested an R2000 house. I've tested tons of Energy Star. Yeah. So, but like I said, the next major level up, and it's a huge step, is the passive house. And like I said, there's two churches. There's the Phi in Europe, and then here in North America, there's FIAS, the passive house US. And I could build a house and have it certified to either one. You're allowed to go to whatever church you want. We're all agnostic of that. We just want the performance, and that's what we're going to focus on today. So this is where we really want you to focus on passive house. That's your stretch goal. All right. So just to put things in perspective, and this is kind of, I kind of threw this together here. This slide is not terribly accurate, but it'll give you the picture. This is more in the US. So a typical older building. So this might be my house. This is the energy consumption per square foot per year. So my house would be, at 79,000 BTUs per square foot per year. Okay. Whereas an Ontario Building Code compliant house might only be 50,000. Okay. Energy Star would be, 45. R2000 maybe 35. Okay. Whereas the passive house, we're way down here. It's like it's almost an order of magnitude. Okay, not quite, but it's a huge shift. Yeah, it is an order of magnitude. It goes from 250 down to just two significant digits down below 50. So it's a huge change. Okay, almost by a factor of 10. Okay, so that's where we want to be. We want to have resilient houses that are energy efficient, and ideally you go off grid, but that's not a key concern for a lot of people. So core concept of passive house, you should pull out your calculator and your slide rule right now, because we're going to delve into a lot of math. Okay, I'm joking. You guys are a quiet bunch. I taught building science at McMaster a year and a half ago for a semester, and then they offered me the second year, and I was like, nah, no thanks. They wanted me to do it in person, and it was too much to travel to and from. But man, they were a quiet bunch. Nobody showed their face online, and a whole semester, just me talking. And I'm feeling the same thing right now. I don't know if I should be mindful. Do I have like spinach on my teeth here? I don't know. Anyhow, nobody to tell me anything, give me feedback. It's a lonely place up here. So which envelope is more efficient? This is Ed Marion, a builder in Oakville who builds passive houses. This is his analogy. This is his slide. We got the we got the coffee cup on the one side, and we've got a thermos. And I know you're all going to say it's the coffee cup, but you would all be wrong, because it's not. It's the most efficient. Sorry, that was a bad joke. See, you're not responding, so I can say whatever I want. It's the thermos. What makes the thermos so efficient? It's well insulated, right? Sometimes there's a vacuum in them. I don't think they put a vacuum in them anymore, but maybe they do. What do I know? A vacuum between the two walls, I don't know. But all I know is that it's probably air, and there's very little conductivity going through the wall. So it's good insulation, and it's super airtight. Okay, in fact, it's liquid tight. So, coffee cup over here is going to last, 20 minutes on a cold day in December or January, maybe, if you're lucky. Maybe you'll want, and that's the resilient choice. Okay, so that's what I want you guys to focus on. So the concept of passive house are simple. It's about super insulation, reducing heat loss with super insulation. We take a great deal of care in designing and planning and speccing a lot of insulation and a lot of it is continuous. Okay, so it's not all like in the middle of a 2x6 or 2x8. It's not like we take 2x12s and we insulate between the 2x12s. There's continuous insulation. I'll talk about that later. So really, it's about reducing heat loss through the envelope with superb insulation. Next, we control the air going in and out like a fiend. We draw a red line right around there. All the components that are part of the air barrier system, the building code, Ontario Building Code talks about an air barrier system, okay? All these components, the 6-mil poly, the spray foam, the window, the door, those are all components of an air barrier system. All of those components are tied together, lapped, sealed, and permanent. It has to be a durable assembly. We want an airtight air barrier system. Okay, we'll talk about we're in ventilation systems like HRVs, ERVs. Make them pay for themselves by making your building as tight as possible. Okay, so again, you got to redline your building. You want a super airtight building. And I know in a retrofit situation, you guys are like me. You got an old house. How do you put an air barrier in it? It can be done. Okay, it's complicated. It's not always simple, and that's where getting professional help sometimes helps. The next core concept is reducing heating losses through thermal bridges. So a lot of times there are structural elements around windows, doors, where you have maybe a piece of steel that's hidden somewhere. Well, in a passive house, we try to limit where the position of, or we try to control the position of that piece of steel by putting it either on the inside or the outside of the insulation. It's usually not right in the middle. If it is, we make sure there's lots of continuous insulation on both sides. Okay, so we really obsess about thermal bridges. We reduce air infiltration and super insulation. The next concept is about the heat. What do we do with heat? Where do we get it? Well, first, because we have superb insulation, we capture and retain the heat of people in that building. Okay, so when we're each person is like a 100-watt light bulb or 150-watt light bulb, depending on your size. You're putting out constant heat, right? You're radiating outside. You're putting infrared heat to the outside world everywhere, even when it's cold, even when it's hot outside. Your body is radiating heat outwards. That's what metabolism is all about. That's go sandwich. So these super insulated houses actually count on having people in it. When you design a mechanical system, you know that there's going to be 5 people living in that house, and you account for it. Okay. The next is we are capturing heat from equipment. So fridges, stoves, VCRs. VCRs. You guys don't have VCRs anymore. CD-ROMs, all that good stuff. Netflix, those TV boxes, they put out a lot of heat. Computer screens, for sure, they put out a lot of heat. So all those devices, you just capture it in a passive house. And finally, what you do is you harvest the energy from the sun. And when I say harvest the energy from the sun, it means ideally your house is oriented towards the sun, and that face that's facing the sun has got most of the windows in it. And the position of the windows, either upper on the wall, low on the wall, or small, or big, or maybe there's a, I'm looking out, maybe there's like an eaves right here that shades the house part of the time, like here. Okay, you're designing all of this. Okay, before the house is built, it's all designed. Okay, so when a passive, you optimize the heck out of every detail. There's no stone left unturned, and they're keeping on. They're ratcheting it up every year. They're just perfecting things every year. Okay, so when you harvest the sun, you'll harvest it specifically with winter in mind. You don't want to harvest the sun in the middle of winter, right? So again, all of that stuff is thought about winter versus summer, and this does a nice job here of showing you, how the eave here really controls the harvesting of sun energy in the winter versus the summer. Okay, again, if that sill was a little bit lower or if it was higher, you can exclude the sun more, spring, fall, whatever. And finally, a key concept of passive house is providing fresh air. Now, Ontario Building Code requires this. So passive house requires nothing different, okay? As of a couple of years ago, I think 2012, or no, it was 2014, we got rid of what Joe Stiebrecht, who's kind of like the godfather, U of T godfather of passive house, or not passive house, building science, along with John Straub at Waterloo, two of the really key figures in building science. He calls exhaust fans, which most of you guys probably just have suck only ventilation. Okay, so it sucks out the air and it's gone. Okay, but an HRV, we're going to talk a little bit about it, or an ERV. In a lot of our cases, we'll want to go with an ERV. What we're doing is we're exchanging the air inside and outside, one volume out, one volume in, and before they pass by each other, they impart the heat from one to the next. Okay, heat moves from more to less. Okay, so it's not perfect, but the energy efficiency in them are pretty good. So to wrap things up, you can live in a house like mine that had fireplaces on a couple of floors, and people made a little coal fire. They put on big sweaters. You can see here the R value in the wall, these skinny little walls here, and a big chimney. That was the way you built them back in the the late 1800s, early 1900s. So now, as of a few years ago, 20th century, it was technical hubris. We're going to solve this with mechanical equipment everywhere. And I'm telling you, some of these places, you go into them, and the homeowner, they might have a lot of money, but they've been sold a mechanical room that they do not know how to maintain themselves. And it's a little bit overwhelming, So really, we enter the 21st century where the mechanical systems are diminutive, they're small, they're efficient, they're quiet, you don't hear them, they don't churn, they don't hum. It's a quiet house. You can see the thick walls, lots of insulation. We're harvesting the energy from the sun. We're using the energy from this little human here, okay? So this little human is not wearing a sweater, they're comfortable, okay? Just like this guy, but there's a lot more thought that went into building this building. Okay, wrapping things up, origami and complexity. Origami is beautiful. Complex architecture is beautiful. I don't know if you guys have been to the ROM in Toronto, but every time it snows, it's a mockery. It makes such a mockery of this design, because the snow falls on this, and all that snow falls down, and guess what? It falls right in front of the gift shop. And after a snow dumping, you cannot get in and out of the snow the snow shop, the gift shop. Okay, it's ridiculous. It's such, the designer had no regard for the climate that this building is situated in. And I know that you guys are not going to do that. Okay, so a lot of people say that passive houses are boxy but beautiful. Maybe they're a little bit too simple in shape, but whatever. Versus this, this becomes like a radiator, and it loses. It has accelerated heat loss. And maybe this works in Beverly Hills, where you get that cool, dry air all the time, or in San Francisco. Actually, I shouldn't say that about Beverly Hills. I don't know about Beverly Hills, but in Northern California, you might be able to get away with something like this with very little insulation. But typically, we don't want to build like that, and your house doesn't look like that anyhow. So this is what I mean about complexity. We want to try and avoid this, and this is the kind of stuff that people find out. This is from a guy down in Georgia, Allison Bales, who's writing a book on building science. Great guy who puts out a great blog, Energy Vanguard. So a lot of great websites out there for you guys. Obviously, you guys have discovered the internet. So upgrading your house. This is where, we're stuck. We're not building a new house necessarily. We're trying to deal with an existing building, and an existing building comes with a lot of challenges, and it's not always straightforward. And so, you know, it wouldn't be surprising to me that you would rely heavily on some experts around you. And this is a key slide here. So this is another one of the takeaways I want you to sort of have this in mind, okay? It's missing the word ventilation here, okay? So that's where, you know, I would ask that whoever made this Maslow's hierarchy of upgrades, building upgrades, should include ventilation somewhere. Oh, sorry, insulating and ventilation is down here. Sorry, you know something, I put it up here. So my mistake, I gotta delete that. Nah, slide, terrible. Who put this slide together anyways? So what we have though here is, sorry, see, I get all nervous and because I've been caught here, caught red-handed. So as you move up the do-it-yourself to the renewable energy at the top, it's increased complexity, increased investment, okay? And if there's a key that I want you to bring here, is that the first thing you do is you stop energy from bleeding out of your building envelope. So that's the first thing you do, okay? That's why up here we have heating and cooling, windows and renewable energy. Windows, surprisingly, unless you've got single pane windows and or your double panes are leaking air like crazy, it's surprising how little energy windows in an average building envelope, you know, in an older building envelope, it's surprising how little they change the metrics or the savings. Typically, Windows heating system, you change that later once the building envelope is really well air sealed and insulated. Okay, we'll just sort of go through this here. Priority number one is understanding. Okay, so what is the weakest link? You know, I've energy audited thousands of houses, and one thing that has always surprised me was just how you know, I always walk into a house thinking, oh yeah, I know what I'm going to see in this house. I'm going to see this, this, and this, and then invariably, one of them just throws you right off. You're like, oh wow, I didn't expect to see that. You know, they've already insulated, or there's like, you know, there's this stuffed bear in the closet. Like, what's with this? You know, my daughter was just asking me, hey, you know, what's that religion where they pack a lot of food? And yeah, you know, I was in the house of a couple where they said, well, yeah, can you check out the attic? There's a bunch of stuff up there. We're not sure what it is. So I get up there, and I think they were Mormons, the previous owner. They had vacuum packed all kinds of dry goods, water filtration kits, medical emergency, everything was canned, and it came with a can opener. And they had boxed everything. And we're talking enough to fill, you know, probably, you know, a bathroom, that volume of boxes up in the attic. So all this to say that you never know what your weakest link is going to be in your house, and there's always going to be surprises. You start opening things up, prepare yourself, just gird yourself, you know, prepare yourself to, you know, anticipate surprises. So it's important to identify the weakest link, and they may not be your windows. Okay, so every house is going to look different, but on average for a pre-World War II home, it kind of breaks down like this. But your house, I guarantee you, is going to be different. Okay, they always are. You know, they're a little bit different, and you want to pay attention to these bar graphs. And the only way you get a bar graph like this is through an energy audit. Okay, so you typically break down, so you can see the air leakage and ventilation. You know, for most older houses pre-1960, this is the #1 heat loss in a building. It's all due to air leakage. Okay, the next, it could be windows, but typically it's the main walls or the basement walls, doors, and the ceiling. The ceiling is usually, you know, unless it's a big bungalow, where you know, a bungalow would be like this, big attic, okay? Whereas a two-story house would have a little bit more wall area than our bungalow. Bungalow is a little bit of wall area, but a 2-story house has very little attic. Okay, it's only got this amount of attic here. I should have a Kleenex box right here, like this Cadbury box. So there's your bungalow, lots of attic space, wall space. Your 2-story house typically looks like this, so narrow, lots of wall space, but it's got very little proportionally of attic space. I've got a 3-story house, so I've got a lot of wall area, but my house is actually attached on one side, so I'm not losing heat on that one side, but I am losing a lot of heat through the outside walls, and my attic is super small. So my breakdown might look like this, where I can insulate the ceiling all I want. I'm not going to get a huge amount of savings there. So first thing you do is you learn energy audit of house, online resources, new construction design. You got to do energy simulations, and remember, no 2 houses are the same. Look at that handsome guy. Get an energy audit done. So I used to work for Greensaver back in the day. Typically, you'll do a blower door test, and they'll go around, and you're basically looking at the entire fabric of the building envelope, and you're trying to component by component just spec it out. How much wall insulation is in this wall? How much is in the basement walls? How much is in the 3rd floor walls if it's different? How much is in the attic? How much is in the flat roof, etc.? What kind of windows? So you're building a composite image of the building envelope and the mechanical system, and inputting it into a fairly sophisticated piece of software. It hasn't changed in a number of years. HOT 2000. I think they're still using the same core now, but still, nonetheless, with a competent energy auditor. And Waterloo, just great place. You guys you've got great great people working there. I used to do some work with them back in the day when I was doing home energy audits and that kind of stuff. So the second priority, after you've learned everything, after you know everything, now you're ready to do some stuff. The no to low cost stuff, this do-it-yourself stuff, the stuff that every house should have anyhow. First thing is changing habits. Probably the hardest thing to do. Turn the lights off, shut the front door, as they like to yell. Changing social habits, powerful strategy for saving, and measure your consumption. For instance, here, Toronto Hydro, I could find out exactly, like, oh my God, like, why am I spending so much money, at 6 o'clock in the evening? What am I doing? Oh yes, I'm cooking, and maybe I'm doing laundry at the same time. Maybe I could do that at a lower priced time. Maybe I can eat at midnight, and I'm just joking. So yeah, it's about shifting patterns, but this is a great place to actually learn about like what's going on, both with your gas bill and actually you won't get that in your gas bill. Sorry, with your but gas bills, yeah, for sure. Winter versus summer might give you an idea of like, okay, summer is all hot water use versus winter, all summer, actually it might include barbecue if you have a natural gas barbecue, but yeah, you could subtract that baseline of hot water heating and find out how much hot water heating am I actually spending versus heating during the winter type of deal. But the electricity one is fantastic. It gives you data, almost in real time nowadays. Not quite, but it's pretty good. It'll give you averages for sure. Next thing you do, turn down the hot water heater. If you can. Sometimes you can't because you need to store that thermal mass of a lot of water. Maybe you've got a big load. You've got, I grew up in a family of 10 kids. We had an electric water heater. My dad was an electrician, and there were no 3 showers in a row. You had to stagger showers and that kind of thing. So, really what we should have done is, installed a bigger tank possibly, or my dad used to turn the hot water, the valve to the shower off down in the basement if it was more than, X number of minutes. So that's one way of saving energy, just get that valve, and whenever your kids, those teenagers, I tell you. Wrap your hot water heater in an insulating blanket, hot water heater, and same thing with the tubing that radiates out all of the copper tubing that has hot water, insulated. This is relatively inexpensive stuff, and it pays for itself usually pretty quickly if you can find the insulation on sale. Installing a programmable thermostat, turning the temperature down during evenings and weekends. Those are strategies that can save you a little bit of energy. Unless you've got like a radiator system, more for forced air with a programmable thermostat. Installing low flow shower heads and tap aerators. Those are the kinds of things that work well at reducing the amount of water that we consume. And you remember, we did have the that pie graph that showed water is a pretty significant load, and increasingly in new homes, the BTU output of furnaces now in a code-built Ontario home and in an average home. Surprising, the gas line going to the furnace is actually smaller than the gas line going to the hot water heater. And oftentimes the hot water heater has a higher firing rate than the furnace, which is a good sign that the Ontario Building Code is pushing people in the right direction as far as energy efficiency goes. But still, I find that pretty surprising that some of the bigger loads in newer houses are the water load. Or at least that spot load, that instantaneous load hourly. It's a peak thing as opposed to throughout the winter. Next is turn off entertainment centers with power bar. So I've done that here. Typically everything's plugged into it: TV, component, stereo, etc. When we're done using it in the basement, we just turn it off. Unplug devices if you know that there's a lot of phantom load going through it. And one of the ways to tell if there's phantom load, if you put your hand on it, it feels warm. That's electric radiant heating right there, and you're paying for it. So all those little devices that cell phone chargers, they do consume an amount of energy. The new ones are obviously very good. You don't feel a lot of heat coming off of them, but the old school black boxes, all of these. Whenever you see a black box like that, it's a transformer in there, and they get warm. They should be unplugged, generally speaking, if you can. Otherwise, you're just heating the place up. Routine maintenance, new filters on furnace and dehumidifiers. Clean out dehumidifiers every once in a while. They get pretty gross. Priority number 3, lighting. This is a simple one, made partially simpler by the province. Phasing out incandescent. Having said that, we still have a ton of halogen lights, which are kind of the same thing. So really, what we should all be doing in terms of energy savings and the price per lumens really is, you can see, sorry, my desk here is very reflective, and my mouse kind of freaks out. It does some stuff here. So you can see here along the bottom in a 1600 lumen bulb versus a 450 lumen. So in the bigger bulbs, the LEDs and the CFLs, at 19 versus 20 watts for the same amount of light, it's kind of a wash. But in smaller lights, LEDs really do shine. The other thing that's fantastic about LEDs is they last a lot longer, and getting rid of them is easier. I don't know if they could be recycled. I don't know, but all I know is they last a lot longer, and there's no mercury in them. That's the problem with CFLs, compact fluorescents. Here, these twirly bulbs. You should not be breaking them, putting them in the garbage. They should be recycled ideally, because the mercury eventually gets back, in our landfills or whatever. It's so much to think about, really, when we want to do the right thing. Priority number 4 is air sealing. Okay, so this is kind of an interesting graph put together by the guys at RDH out of Waterloo and BC. They've got offices, big engineering firm, originally Canadian firm, but they came up with this great visual. So these are all the things that we want to control in our buildings. We want to control water. You know, if it rains outside, we want to control it. Air leakage, air flow, we want to control it. Heat going through our building envelope, we want to control it. Vapor going through our building envelope, we want to control that for sure. Sound, we don't want the dump truck sound coming through our walls, our windows all the time. So we want to control sound, and for sure we want to control fire. And on this side, we've got, you know, the building form and features, the water shedding surfaces, water resistant barriers. So that would be your Tyvek Type R, you know, airtight barrier system. Maybe those are windows, maybe those are 6 mil poly, maybe that's spray foam, you know, thermal insulation, maybe that's spray foam, maybe that's rock wool, you know, and then vapor retarder barrier. Well, that's definitely, you know, it could be the paint on your wall. Maybe that's the vapor retarder. Maybe you've got a 6 mil poly. Okay. But how do these different components, what controls what? We'll go through it here. So, controlling water in our building, these are the components: building form, water shedding surfaces, water resistant barriers, and sometimes to a lesser degree an air barrier system. Okay. What controls air? It's the air barrier system. What controls heat flow? It's both the air barrier system and the thermal insulation. What controls vapor flow through our buildings? It's the air barrier system. It's the thermal insulation. It's the vapor retarder. What controls sound? It's the thermal insulation, right? If it's dense insulation like a you know, like a fibrous insulation like cellulose or rock wool, or, you know, fiberglass to a lesser extent, that dense insulation tends to cut sound. What else? Making a building airtight. When it's airtight, the noise doesn't get through the crack. It's amazing how much noise comes through cracks. And then the systems that control fire typically are parts of the air barrier system, right? Whenever in high rise, we air seal with that red caulking, all of the fire separations, and thermal insulation. We rely on these things to control fire. So what I'm trying to say here ultimately is that we want to control water. Water in all of its forms is just brutal, okay? And, you know, the IPCC says that the number one thing homeowners need to prepare for in a changing climate is overland flooding. It's going to be the number one most disruptive thing for all of us. And so, you know, we got to think about that, you know, it's about resiliency. But so today in these control strategies, we want to try and limit the amount of rainwater that comes in, okay, and vapor, okay? So these are both water and vapor, okay? So now, you know, these are the control strategies. The air barrier system plays a key role in both vapor and water control, okay? But mostly vapor, and we want, you know, we'll rely quite heavily on that. Of course, water, you know, building form, the roof, shingles, eaves trough, etc. That's key to keeping rainwater and snow out of our buildings. But yeah, we want to focus on vapor. So wrapping things up with this air tightness thing, things you can do is air seal inside your house. You can caulk the trim and baseboard spray foam. If you have your house energy audited, what you can do is be there when that person comes to test your house. If she pulls out when she pulls out the blower door, you know, you can follow her around. If she does, you know, maybe you can feel for air leakage at all of these different places. I used to use sticky notes and put them in all the places, you know, baseboards that leaked air, pipe penetrations that went through the wall. I put my sticky notes throughout the house, following the, I did it myself. I was the energy auditor. Attic floor air sealing. So it's really, we'll talk a little bit about attics in a bit, but it's important that before you add insulation to an attic, you air seal the attic floor. And some of you may have had an ice dam or problems, or currently having problems with ice damming or ice buildup on your roof. You know, it doesn't have to be that way necessarily. Now, some roofs are just poorly designed and they're more prone to ice and snow building up on them, ice particularly, but generally speaking, a lot of problems with water prematurely melting on a roof tend to be with air leakage going from the living space up through stack effect, pushing it into the attic. Okay, so I used to do a lot of retrofitting of houses when I was at Green Saver. I did a lot of work myself there for a number of years. So weather strip doors and windows. Note that if floor joists rest in rubble, there are risks. I'll show you a picture of that a little bit later on. Here's a picture of a guy, Green Saver, caulking windows. Okay, the holes in the wall were for injecting either cellulose, or I think at the time they were doing a little bit, they were experimenting with injecting spray foam in a cavity as well. So, which you know, is interesting. Air sealing your house has many benefits. So it lowers the energy costs in summer and winter, keeps more humidity indoors during the winter and less in summer, makes for a more durable building. There's less noise and dust from the outside. So we talked a little bit about ice damming. This is typically typical of ice damming. I wrote an article for Home Energy magazine a number of years back on ice dams, all the ice dams that I had the chance to go and check out, or report back and try to fix. Typically, again, it's the attic volume that heats up. It melts the snow. The snow turns from solid, it turns from solid to liquid, and it goes downhill. And eventually it gets to the eave where it's cold. There's not as much radiant heat and air leakage, and it solidifies again. And it creates this big bump of ice on the eave, and the ice just slowly builds and melts, builds and melts, okay? So the root cause is often air leakage. Keep that in mind. When it comes to appliances, I know you guys probably don't care about appliances too much, but the quick few notes. More efficient appliances are out there than the ones that you currently have. They will save you money and usually last a little bit longer if you buy for efficiency. So, but you can't always see the difference. So look for a third-party label or certification, and the Energy Guide or Energy Star labels now are perfect. So just remember that Energy Star labels are best in class. So you know, the avocado green Energy Star fridge advertised on Kijiji for $50 may not be worth it. Okay, so just keep that in mind when you're going for best in class. So yeah, you know, whether you want you have an electric stove, an electric range, or you know, be conventional radiant, or if you have a the elements are not radiant, if they happen to be induction, you know, slightly more efficient, a little bit quicker, more responsive, but a lot more expensive out of the gate, etc. So whereas with gas, well, it's a gas stove, you know, it is what it is. There's not a lot of room to move up with the gas stove. Dishwashers and clothes washers, dryers with delayed timers are nice, so that if you wanted to delay your peak purchase of energy, always a good thing, always a good feature to invest in. When you use the Energy Star, usually it'll point you to appliances that are made with better components. Okay, it's not to say that you can have a bad batch of Energy Star rated, but typically they're best in class, and they typically have better quality motors. They tend to be DC motors in a lot of cases. You know, just a lot smarter. And you know, DC motors, we'll talk a little bit later. You know, now even in fridges you can get a what they call modulating motor, and that modulating means that if the fridge senses that the temperature's off by only 1 degree Celsius, it'll make the motor just turn a little bit. It'll put out just a little bit to match that load. But if somebody's just opened the door for half an hour while they loaded this still warm turkey into the fridge, and then they close the door, all that humidity, that, you know, then that motor varies its load and says, okay, wow, it's now plus 25 in the fridge, I go full speed. So that modulating thing, you'll see that in furnace motors, and a lot of controls for even fridges have modulating output motors now. So certainly invest in good quality motors. The appliances should last you a lot longer. And they tend to be quieter as well. So that's the beautiful thing. Instead of paying money to make a lot of noise, that money is steadfastly focused on doing work and not making noise. Okay, when it comes to insulation, attics, we insulate walls, we insulate foundations and crawl spaces. And you know, believe it or not, you lose quite a bit of heat through your slab in your basement. So especially if you live in an area where the soil is really wet, that wet soil is very good at conducting heat away from the slab and making you uncomfortable. Okay, so the goal is always keep your eye on the, you know, I'm trying to remind myself because I'm the kind of person that can stay myopically focused on the ball, but I should keep my eye on the game, not on the ball. And this is where you guys, keep your eye on the game here. And the game really is about lowering your heating load and your cooling load. Okay, it's not about that one appliance or whatever. It's definitely about lowering your heating load and cooling load. So it's an investment in the envelope. Okay. Insulation. We often think of insulation in the plane of the wall structure, example between 2x6s. So the next level kind of thinking involves continuous insulation. Okay, so that's a layer of insulation. So for instance, here you can see in this this cutaway here of the stud wall, there's a stud there, we've got insulation in that plane. But here we have continuous insulation on the outside. Okay, so again, that whole idea of having continuous insulation either on the inside or the outside is key, and now it's incorporated in the Ontario Building Code. Okay, here is a good example of what you might want to do in a basement. For instance, if you frame it out, you frame out your wall and you space it away from the wall and you spray foam first, so you get that continuous level of insulation behind the studs. It's one monolithic coat, so it's airtight typically, and you got the heat loss at the studs is reduced. Okay, so there's lots of different types of attics out there. I don't know which one you have. We can talk about it later, but they all pose problems. I've done a lot of work in air sealing this section here of knee walls in 1.5-story buildings, trusses in more modern buildings. You know, this mansard style roof, these are just terrible for ice damming, and they can be a real challenge. So again, you know, insulating along here, or do you just insulate all along the rafter? Those are tough choices that you can make with a contractor and an energy advisor in tow. The three predominant wall types in Ontario tend to be pre-World War II. So uninsulated walls, double brick or wood frame. Post-World War II boom, insulated block, uninsulated block and bricks, or just concrete block all the way. Early 1970s tend to be wood frame, partially insulated. Late 1970s or original actually heated house from 1965 onwards, usually they tend to be insulated. Okay, so we have, so this is my house, double brick with the rubble. Okay, so this, you can have issues with joists that rest in the rubble if they were in the rubble. Mine is on the rubble on a mud sill, so it's not too bad. You know, this, you can have quite a bit of moisture migrating up through the foundation in the brick foundation walls. Poured concrete tends to be less prone to that phenomenon of moisture wicking up the wall, but it can still happen. Great, you know, probably the best of the bunch, and then concrete block. Okay, all the different types. So, you know, spray foam is one option. Dense pack insulation is an option. This is an old Victorian house here in Toronto. It's wood frame. It looks like brick on the outside. The side is stucco though, and it is in fact wood framed all around. Here's a guy who I'm one of my past energy advisors, Pat Kerr, who's now doing energy auditing in Vancouver. Great, still in the biz some 20 years later. So dense pack cellulose, you know, again, you got to hire a company that knows what they're doing with dense pack cellulose, although, you know, it's one of the most sustainable products out there. it's really tough to find crews in Ontario to do it properly. Okay. Moisture barriers, just remember, so this is from NRC, National Research Council, and NRCan. They would first have you protect your walls. So just assume that water will eventually one day build against the dirt, the frozen dirt, and it will push water in through your foundation. So just assume that a couple of inches above grade, that water might be pushed through the wall. So you put a sheet of plastic, something impermeable that will guide the water directly to the footing and below. And then you can build your wall. We know that it's going to be protected from water. So we don't put that poly all the way up because, we want that wall to somehow dry out to the outside through the concrete if it can, okay? Not a lot of moisture will go, but some moisture will get through the concrete, okay? So where do you air seal, blocking, all these details, people can help you out, contractors can help you out. And again, that 6 mil poly you can see here, just from grade all the way down, it comes out here. Again, all these details are on the Government Canada's website, the Office of Energy Efficiency, or NRCan. Spray foam in the basement headers. Sometimes it air seals. It's not always a great air sealer, spray foam. So you got to be careful with spray foam. It's not the solution to everything. So be careful. So when you're heating water, so again, we're getting to the top of the pyramid here. Maybe you've got a tank, maybe you got tankless. And I don't really talk about tankless too much in here, but it's certainly an option. They're fantastic devices. You don't have the storage. One of the things you can do is you can recoup some of the energy that typically goes down to the drain. Get a drain water heat recovery unit. And air source heat pump water heaters are also available. Okay. So if you have a tank and pipes, you can upgrade. So as soon as you did the pipe installation, use the Energy Star rating system to make your selection. Okay. The highest efficiency electric tank is the tank volume that matches your domestic needs. So just remember, match the size of the tank to the needs. How many occupants do you have? Big family, big tank, little family, little tank. Okay. For electric tanks, the highest efficiency electric tank is one that's well insulated. And the best ones are typically hybrid air source heat pumps, air source AS HP with electric heating element backup. So it's got 2 heating sources. So typically what an air source heat pump water heater does is it steals heat from waste heat in the laundry and furnace room, typically where most of our hot water heaters tend to be. It steals heat from that room and puts it into the water. Now, if it happens to be really cold in that room, or if there's a big load, then there's a backup electric element in there. So that's why there's 2 heat sources in there. But these devices are being used all over the States. They're particularly great in warmer climates down south. They're just a no-brainer, even if they're a little bit more expensive. Fantastic devices. They're pretty quiet. It has a compressor in it, just like your fridge. So if it's done well, it'll sound like a fridge humming, when it's on. So they do rob heat from the room that the tank is in, which might be good if it's a boiler room with a laundry where there's lots of excess heat, but not good if it's your bedroom. Of course, nobody has a tank in their bedroom, but I don't know about your house. Nothing surprises me anymore. So I talked a little bit about a drain water heat recovery unit. So this is, I have one in my house. What it basically does is while you're taking it only works when you're draining water and using hot water at the same time. So when you're taking your shower, that hot water falls down the pipe and goes back to, it goes to the city main. Now what happens is, or to the city sewer for treatment. What happens in the meantime, as you're drawing water, is you're pulling in cold lake water from the outside, and it goes around this coil and it steals the heat out of your big drain pipe, and it puts it into both the tank and the cold side of your shower. Okay, so really a clever device, and I think there are grants available for it as well. So I have at my house right now, I have an instantaneous. We have 5 people in our family, 2 adults, or well, actually they're pretty much 4 adults and 1 teenager. who's going to be 18. And we've had company over, with low flow shower heads. I have, and a power pipe here. Our old, the instantaneous hot water heater has done quite well. Our bills are pretty low. It's a great device. It's not the highest efficiency at the time when I installed it. It wasn't the best. I think the firing rate on it was like 60,000 BTU. Yeah, the strategies worked here. But I know that, I visit people's houses, and some people want to have like the rainforest shower head where like 75 gallons of water are falling on their head per minute. And, you just need a tank. You can't do an instantaneous for that. So, yeah, for the odd time, we've run 2 showers in this house with one of these devices, and we've done okay. If I didn't have this device, I don't think that we would be able to run 2 showers simultaneously. And the pressure is reduced. So, and that device needs to be cleaned out every once in a while, but so does a hot water tank. The ones made in Japan, they're so durable. It's crazy. The Korean ones as well. They're fantastic. Not to be giving you any brands, but certainly I think those countries tend to use a lot of instantaneous. The other thing you can do is install a heat trap to stop convective heat loss. So typically we talked about convective loops with air. Same thing happens with water. So if you make a trap, you make the hot go up and down. So what happens is coming out of your tank. So if this is your tank here, take any water, the heat, the hot water loops up, cools down, and comes back. Okay, so that's the whole idea behind making a heat trap. Okay, so that's just geometry, putting a little U loop in there. Okay, best in class, air source heat pumps, using CO2 as a refrigerant, but they're insanely expensive, but this kind of technology is out there. Priority number 8, heating, cooling, and ventilation. Okay, so I tucked in the ventilation there, sorry. For gas heating, always buy, the best AFUE and variable speed motor and gas valve that you can possibly buy. Again, for cooling, highest SEER rating, period, okay? Use the Energy Star guides, look for all of that information out there. You'll find it. The next is to, upgrade to an air source heat pump if you don't want to use a furnace. You can use an air source. And then there's ERVs versus HRVs, okay? So for forced air gas furnace, as I said, use Energy Star. If you like to circulate air all the time and have an AC, so that means you're using it in the summer and the winter time, then yeah, install the best quality motor you can possibly buy, and that's typically what they call a variable speed DC motor or an ECM. I've learned that there's a lot of people who play tricks with the word DC motor. I don't know, but the key word here is modulating. You want to buy something that is modulating, okay? Modulating is the word. That's like all the cool kids are using the word modulating these days. So the best variable speed motor furnaces are fully modulating. So a little bit of air, a lot of air, it varies. It's not just a 2-stage where it's medium or high, okay? So yeah, you can even get them with a variable gas outwards. It can make a little bit of flame, medium flame, and then turn the fan the proportionate amount. They're variable, okay? So this is about modulating. So the key word is modulating. Same thing with fridges. For forced air electric furnace, there's really not a lot you can do. The best thing you can possibly do is get rid of electric baseboards and electric. If you can, you'll need to distribute the air. I know it means a mini split in every room. I know, or you can go with a mini split that has a ducted mini split. I'll show you what that looks like. But yeah, electric resistance is dead, okay? It has a place in a toaster, but that's about it. So whenever you see an element, that's electric resistance, it's radiant heat, okay? So instead of using electricity to make heat in a radiant manner. An air source, a heat pump, what a heat pump does is uses electricity through a pump, a motor pump, to move heat from one zone to another. Okay, in your fridge, it moves heat from inside your fridge. I know it doesn't feel hot inside your fridge, but there's still a little bit of warmth in there because it's not absolute zero. It moves the heat out of the fridge and into your kitchen. Okay, it's the same thing with a mini split. It moves in the summertime. It moves the heat from inside to outside, and in the wintertime, it moves the heat from outside to inside. And the new air source heat pumps, they can work down. You can still make it cost effective electricity wise to minus 30 degrees Celsius air. That's pretty cold. Anything colder than that, typically you would need electric resistance backup. So, you might still have to have a little bit of electric resistance in there. So I take back what I just said, get rid of electric-based force resistance. But by and large, we know that that's the most expensive type of heat there is. So yeah, there's what they call a ducted mini split. So it's got an indoor unit like that, and you connect the ductwork onto it. Typically, it'll have one or two heads or one or two compressors on the outside. Okay, whereas the standard mini split is what it looks like. It has this distributing unit box on the inside and the compressor on the outside. Okay, so yeah, there's different flavors. Some of them are ducted. They behave more like a furnace. So, this company out of BC makes an air handler unit that you can stick your boiler. So let's say you had a boiler in a hot water tank. Maybe that boiler can produce lots of heat through hot water, and you can circulate it through here. So there's lots of options out there, but they tend to get a little bit more expensive, more premium. And find a good technician who can cobble these systems together. And that's the nice thing about these units. They're all factory made in, and a lot of them are made in China, offshore, but they're all made in ISO 9000 factories, and they're all made exactly the same way, so the consistency that you get with these units are very good. They're very consistent. Okay, so here's what a ducted air source heat pump that's fully ducted would look like. Okay, so you have like this, it looks like a carcass of a standard furnace. Okay, the air would come in down here and go up here, and you have your coil in here. So your refrigerant coil. Ventilation, build tight, ventilate right. So make the building as airtight as possible. Like I said already, it's already mandatory that the building code, you need to have balanced ventilation. So that means an HRV or an ERV. So if you invest in ERV or HRV, make sure that the device earns its keep by making your house super airtight, as I've already said. So we've already talked about this. One of the big differences between an ERV and an HRV is that an ERV typically doesn't have this little condensate trap here. So maybe a bit easier, a bit simpler to install at times. Both need routine maintenance on filter cleaning the filters. Okay. ERVs trump HRVs for keeping the humidity where you want it, inside for the winter, outside for the summer. If it's humid where you live, get an ERV. Okay, if you live in a place like here in Toronto, it's getting to the point where we just got air conditioning put in last year for the first time. I've lived without air conditioning, but I can just tell you that the house the basement starts to get moldy by the end of August, September. It's not a pleasant smell down there. So ground source heat pumps, the verdict is pretty much that air source heat pumps beat the performance before ground source heat pumps. So the verdict is, if you can, go with air source heat pumps. I know that ground source heat pumps, you might be able to get a lot more load, and typically they're installed in mansions, huge mansions. So getting air source heat pumps to heat a mansion, it gets really expensive mechanically. So I understand the appeal of ground source heat pumps, but ground source heat pumps, the issue with them is that the bore field gets tapped out. So in other words, by the end of February, you've sucked out all of the heat that you could possibly get out of that soil. And maybe, you thought you were getting wells, but they installed a slinky. And maybe the pipe diameter you thought was this, but they installed this. There's so many variables because it's not made in the factory consistently day in, day out. The field installation, it's just subject to the vagaries of the installer. And all I know is I've been to lots of new houses with ground source heat pumps. It's hard to find guys who will diagnose the problems with these ground source heat pumps. And B, it's hard to find companies that actually just do a consistently good job. And maybe it's the fact that I get called to all the lemon jobs, but let's just say that, I've seen many castles, beautiful cottages on ski slopes that have crappy ground source heat pumps, and they're stuck using electric baseboard heaters as a backup heat because their system just doesn't work together. So if you compare ground source heat pump to air source heat pumps, the predictability and the performance of air source heat pumps outshines ground source heat pumps every time. Number 9, windows. Buy an Energy Star rated. I think every window, you can buy windows. There's a little window shop down the street. There's a number of them here in Toronto. I can buy an unrated window anytime I want. But really, if you're investing in a house, you need to know what's in there, and you should make sure that they come with the coatings that you ordered. If you ordered argon, you want to make sure there's argon in there. And typically, the IGU or the glass portion is made by a third party in a big factory, and your local window company will take that IGU and put it into a frame. Okay, so that's typically what a lot of small window companies, mom and pop shops do. They buy generic vinyl frames or wood, and some of them still make their own IGUs. If they make their own IGUs, a lot of times you're limited to the types of coatings that you can get. But your priority with windows should be to get the most energy efficient window you can get. With an insulated frame, it's hard to find insulated frames even now. You got to pay a lot for them. Fiberglass tends to be a good window because it's a very strong, rigid frame. It has the desirability of aluminum. This strength and thinner profile that aluminum typically has, but it also has very little expansion coefficient. So it tends to be a window that lasts a long time because it doesn't put a lot of stress on the sealants that assemble it. And get double pane or more, obviously, the more the better. So this is what you use. And remember that the U factor here, you don't want a high score here. You want a lower score. The lower the U factor, the better, okay? So solar heat gains, yeah, so sometimes you want high solar heat gain on the south side, low solar heat gain on the east and west side, because, if you get hammered in the living room, which is on the west side, in spring and fall, and you're all of a sudden you need the air conditioner on, it doesn't make sense, So you tweak and you adjust, you optimize the coatings for the location that the window serves. And you only do that with software. And it's something that you have to pay somebody to actually do with energy modeling. Remember that fixed windows are more efficient than operable. Triple pane cuts out a lot of noise, but it's really heavy and needs more structure to hold it up, especially if it's operable. And then there's coatings. There's a ton of coatings out there. Pittsburgh Paint Group, there's all these different companies that make glass. They put sputter coatings on them. There's very specialized coatings, and everyone's got their own secret sauce out there, okay? So it's not just low E. There's probably 30 or 40 different types of low E out there. There are different formulations out there. So yeah, you want to, and again, energy modeling software is what you would use to optimize all those coatings on your windows. Priority number 10 is renewable energy, and I'm not going to talk a lot about it. I did install solar hot water systems back when I was Green Saver. I was on the roof installing these systems, and my advice to you is, because solar hot water, you get a lot of hot water when you don't need it. In the summer, you got to dump off the hot water. There's systems that are prone to a lot of repair. maintenance. I think that if you're going to use your real estate for something, invest in solar photovoltaic. So solar electric is the way to go. It's a higher quality energy. You could do a lot more with it. This is my opinion, but yeah, solar hot water. There's some new technologies that are coming out that include what they call PVT, photovoltaic and thermal. So that should be interesting. You know, if you can keep people, it'll produce a little bit more electricity. So hopefully that comes on board. But yeah, if you need, remember, we're right at the apex now. So you only invest in this in renewables once you've done everything else. Okay, so it's the last thing that you do. Okay, I did everything else. Now what? These systems are expensive. Consider renewables only if you minimize your heating and cooling and water loads. For useful energy, PV trumps hot water unless the latter is for a pool. So if you got a pool, you know, you can buy cheaper pool heaters on a roof that you put on the garage. Yeah, I'm totally for that. It's great. How conservation works, to wrap things up, it's one part appliance and one part behavior. It's not, now that I have more insulation, I can kick up the thermostat a notch, okay? So, and just one final note about thermal mass. Thermal mass is a concept that gives and receives daily. So, okay, it's a 24-hour cycle. That's what thermal mass does. It operates in a 24-hour cycle typically, unless you're storing energy in a big, massive car-sized tank somewhere underneath your basement, which nobody really does. Forget it. Most thermal mass projects, they behave like a hammer. The sun charges it, and sometimes you get that hammer when you don't want it. So you got to design it if you want to use it, but by and large, most high performance buildings like Passive House, they don't really consider thermal mass as something that they that they obsess about too much. But you can use it, and it does work. Programs, I'm not going to cover them. They're out there. I'd rather answer your questions if you have any. Sorry, I took a lot more time than I deserve to.
All right, thanks. Thanks, Greg. If you could stop your screen share.
I'm going to do that right now, if I can figure that out.
Okay. Should be a big stop button there somewhere.
Right. Here. I've got the two screens going on here. Okay, stop share. There we go.
Great. Thank you. And at this time, I want to thank Greg for that presentation, and I'm going to ask our panelists who have been sitting in the wings and ready to answer questions to go ahead and turn on their videos. And just to do some quick introductions here with the people that we have tonight. Greg's gone over a lot of information, but we have some people who would be happy to answer questions in a number of different areas. And those areas, you know, the people that we have with us tonight are homeowners who have done retrofits in many of the areas that Greg has talked about, everything from windows, insulation, various types of heat pumps, including air source, ground source, and water source. Also heat pump water heaters and solar panels. I know we didn't get a chance to talk a lot about solar panels tonight, but if you do have questions for someone who does have solar panels, we do have some folks with us tonight that can try to answer those questions for us. And so I'm going to, just before turning it over to Garner, who has been sitting in the background here looking at some of your questions, I want to introduce the other folks that are with us. On the homeowner side, we have Neil Lackey, Kevin Thomason, Stephen Clark, Larry Kursky, Katie Honig, and Shaw Forgeron, and myself too. I've recently put an air source heat pump in. So we all have a variety of experiences with doing some retrofits, and be happy to answer questions that you might have. And also we have with us some people that are a little bit more with a little bit more expertise than us homeowners have. Devin Calder, who is the Climate Action Plan Manager at Climate Action Waterloo Region, and Jim Bolger, who is the owner of a heating, ventilation, and air conditioning company and also the past head of the Ontario Geothermal Association. Both Devin and Jim also were members or are members of the Natural, I don't know if it's Natural Resources Canada or Natural Research Center. I got that wrong maybe, but it's the National Space Heating Working Group. So we've got a fair amount of expertise from those folks that have joined us tonight. So without further ado, we'll try to answer as many questions as we can in the time that we have left. Just remember that if you don't get your question answered tonight, please feel free to send, when we send out the email with people's email contact information, feel free to send an email to any one of the panelists if you didn't get your question answered, or if you have another question you'd like to get answered in more detail, you can certainly contact our panelists after the webinar. So I am going to turn things over to Garner and get the Q&A started.
Okay, great. Thanks, Tom. And I'll just remind the panelists too, just I'm going to ask the questions to Greg, but if you want to chime in on any of the questions, even if I don't direct them to you, just raise your hand or click the little raise hand thing on Zoom there. Okay, so Greg, starting off, a few questions from the chat. Sheila asked, what strategies are used for keeping birds from hitting passive solar windows?
Wow. Yeah, you know, I just listened to a podcast on 99% Invisible, and they had an ornithologist talking about, you know, big cities, and, you know, Toronto is one of the few cities that actually mandated, you know, adding a frit or adding something onto the windows to prevent birds from crashing into buildings. And I was stunned that it's, you know, only Toronto. And at that, you know, there's still quite a few bird deaths here because a lot of the buildings don't have frits. But I'll be honest with you, I'm not sure what they mean, but by this question, because one of the things that this podcast did say was that the problem still exists in homes. It's just way more diffuse. You know, when you have a tall building that's 80 stories, of course you'll find a lot more birds, and not only that, but you know, it's in the flight path that much more. So, but I'm not sure, aside from putting some kind of a frit on the window for any window, you know, some kind of a pattern in the window. It's usually baked in the window. I know I worked at U of T School of Architecture, and there was a problem with a fret, and they had to replace all the windows and redo the IGUs. Anyways, these are expensive mistakes. So I think, to answer your question, I would just say that, you know, you can probably buy some kind of a window with some kind of a pattern in it, and I'm sure there's good ornithological you know, sources out there that could guide you in that direction.
Yeah, that's great. And Kevin, you have your hand up?
Yeah, and it's one of those things. I just have completed a new home build that's got a lot of extensive glazing. I live in an environmentally sensitive area, was really concerned about birds hitting the windows. What Greg is talking about when he talks about frit is literally stickers you stick on the window. In Toronto, they mandate that no space can be larger than 10 centimeters without stickers on it, which, while on a commercial window, you can actually do some interesting patterns or things like that. The last thing you want to do is build a new house and then have to cover your windows in vinyl adhesive, and you're not necessarily going to put a logo on it like you might on a storefront or a commercial office building or whatever. What I did discover is in Europe, they have a glass called Ornolux glass, in which they've discovered birds can see infrared, but humans can't. So they actually print, using infrared inks, a pattern into the glass that looks kind of like military camouflage netting. So the birds look at the glass and see netting and don't fly there. We look through the glass, can't see infrared, and just see right through the glass. The unfortunate thing is the Ornolux glass is not available in North America yet. I went to extensive efforts to try to source it, can't find it, even went to the lengths of trying to ship containers of it from Germany over to here. That isn't very carbon friendly, or you know, we tried to source everything local and do our build on a 100-mile diet. So in the end, we've just given up and hope that somebody will, you know, perhaps come up with infrared decals you can print and adhere to glass or such. But the bird strike is a serious issue that we do need to find far better solutions for.
Mm-hmm. Yeah,
that's great. Thanks for that, Kevin. Gail asked, does the 2000 in R2000 refer to the thickness of insulation?
You know, that's a question for an older person, and so I'll answer that. The R2000 was, I guess, started in the 1970s, and they thought, whoa, the year 2000, they'll have everything figured out, and so it refers to a Y2K thing. So yeah, they should rebrand it to R2500 or something like that. I don't know. You know, 2030 is another one that's coming up in for architecture, and I'm like, oh, geez, man, we're almost there, and yet, you know, we've made so little progress, it seems.
Yeah. Okay, moving on. Chantel asked, I live in a basement apartment where the closet has a crawl space for storage, and the crawl space has some insulation in it, but there's a door opening that isn't blocked off. And so she was wondering if she should just be adding a door to that, or maybe adding some more insulation in that space, or what would be a good solution to that space?
Heated or not heated?
Sorry, Greg, you just cut out there for a second.
Oh, sorry. No, you're right. It's saying that my internet connection is unstable here. It's funny because I'm plugged in and yet it shows me on Wi-Fi. Hang on one second. Let me just play with this. Let me see if I can.
While you're figuring that out, I guess we can move on to another question. So maybe the homeowners could weigh in. What are some of the biggest challenges that you all faced in completing your home energy projects? You don't all have to go, but if somebody can raise their hand, that would be helpful. Yeah, Larry? Oh, Larry, you're just muted there. I'll also remind everyone, just since we're short on time, just to try to do your best to keep your answers brief.
When we first had ours installed, there was a failure in a small piece of equipment. There was a pinhole, all of our fluid leaked out, and we didn't realize that we were running on the 10 kilowatt electric heat for probably a week or two. So it was a bit of an expensive experience. But since that's been repaired, everything has been fine.
Sorry, what system was that, Larry?
It's a ground source heat pump. And it's horizontal ground as opposed to vertical.
Okay, interesting. Always things going wrong, I guess. Katie and Shaw?
Yeah, one of the challenges that we faced initially was just finding the right contractor, finding the right organization that wasn't just sort of agreeing with our green initiative, but then recommending things that on closer research were not actually, you know, certified or didn't have the right scores. You know, there were a lot of people that were saying, oh yeah, oh, you know, we've got the, but you really do have to do careful research and look closely at what people are offering you.
Yeah, that links in right with what Greg was saying about the difficulty of finding those contractors to do that type of installation, right? Kevin?
Yeah, well, one of the challenges that we had was finding contractors who could work together. We found, you know, there was people who had done solar and people had done geothermal and people had done timber framing. No one had ever done it all before. So we found we spent a lot of time putting people in the same room and having them work together to figure out how the whole building was going to come together. But that was really worth it. You know, we actually went off to, you know, RDH Building Science or the universities or other places, sat people down around a big table in front of whiteboards, and that wasn't the norm for any of these contractors, but they loved it because they were learning things that they knew would apply to a lot of their builds moving forward. And they put a lot of time and energy into the learning that in the end really helped us pull together a great project. So just because they haven't done it doesn't mean they won't consider it or they aren't interested. And you might be able to find a way to create that incredible 1 + 1 = 3 team by pulling an all-star team together to do what you want.
Yeah, that's awesome. So I guess you just got to push a little harder, right, Kevin?
Yeah, and be creative and push everyone to be creative, and it's amazing the results.
Yeah, Tom?
One of the challenges that we had was with respect to electrical. So no matter what you're doing, don't forget that we moved from a gas furnace to an air source heat pump, and we also want to get an electric vehicle. We also want to get a heat pump water heater. And one day somebody said, you realize that your electrical system is not going to be able to handle all of that, and we had to do an upgrade to 200 amps. So one of the things I would just recommend to everybody is, if you're starting to look at doing some of these things, which are great, don't forget the electrical side and start working on it early. Start getting get an electrical contractor in early. Talk about what it is you're planning on doing, and then it won't be like last minute. Oh, oops, we have to get electrical done before we can put that heat pump in. And you may not need to. Sometimes if you're just putting a heat pump in, some of the other people who have heat pumps may want to chime in on this, but you don't necessarily need to upgrade your electrical just if you're replacing a gas furnace with a heat pump. But if you also want to get an electric vehicle and have a charging station in your garage, etc., just something to keep in mind.
Yeah.
Yeah, that's a great point. And Greg, actually, maybe before we return to Chantal's question, maybe you could speak to that a bit more. Like, how would you go about if you were looking at doing like many projects over maybe like a number of years? Is there like a better sequence to go and do those things? So maybe you're not having to go back and redo work that you've already done. Like if you're going to open up a wall, do things at the same time.
Well, yeah, here's what I can say is my son recently bought a house, and yeah, I thought that I could handle things. I've been on construction sites a lot, and I'm pretty handy. And but one of the things that I was missing was just the planning and thought processes that go behind what typically an architect would offer. These professionals, and I call them professionals with a lot of reverence. And not all architects are some of them build monstrosities downtown that I abhor. But a good architect will just allow you to really plan things and phase things in. I work with a couple of boutique firms in Toronto, and yeah, they'll customize their plans. So this one architect, he's made it so that the project rolls over. They're going to take over the basement while they renovate the main floor, the second floor, and it's all phased in. Like normally you don't do that, but the client had very specific requirements. So, but yeah, I think I definitely getting good advice from people like that, and they also come with a cadre of contractors. They come together with people who have experience. And was it Shaw who was saying he was having a hard time finding people who had lots of opinions but didn't have as comprehensive an overview as your project needed.
Yeah, that's great. Yeah, so you got to hire the right people. So yeah, returning to Chantal's question, just to remind, she said that she lived in a basement. There's a crawl space that has insulation in it, and there's an opening where a small door would go, but there is no door in it. So she's wondering whether the best solution would be to put a door over that space, or maybe to put more insulation in it, or what would be a good solution there?
I don't think Chantal's here anymore, right? Otherwise, I would be peppering her with questions, because the risk of just closing the door is that I don't know. Am I going to orphan that room? Maybe it needs heat. Maybe there's water lines in it that are going to freeze. I just don't know, So, but I mean, if you can see the fiberglass, yeah, I mean, ideally the fiberglass is covered, with drywall or something a little bit more permanent and doesn't show ramshackle, because it sounds to me like it's the visual thing that gets to her. Or maybe it's a mold, I don't know. Maybe she can put drywall up and put a heater in there just to, you know, I don't know. It's hard for me to answer.
Yeah, fair enough. So it's there's no kind of good one size fits all answer to a problem like that. Like, it's probably better to have somebody check it out in person and walk through all the requirements with her.
Yeah.
Okay.
Yeah.
Someone else asked whether you would or wouldn't recommend a programmable thermostat for hot water systems.
Yeah, I mean, for electric, yeah, probably. It's a good question. Where, you know, natural gas is pretty cheap, although, you know, this whole Russia thing is pretty freaky. But yeah, you know, electricity is, you know, you want to try and use that electricity when it's cheaper. And so maybe there's, you know, an ideal time between, you know, 4 and 5 in the morning where you just bump up the temperature of the water for that onslaught of 3 showers in a row at 7 o'clock. I don't know. Yeah, you know, that's the kind of thing that would be, you'd have to match to the client's needs, you know. So, but yeah, I don't know if it would be something that would be useful with a gas, maybe. You know, it's a good question. I've heard of it for electric.
Okay.
You know,
yeah, fair.
You can get so much. Sure, there's fuzzy logic in those tanks. You know, there must be. What is spray foam basement headers? Again, Chantal, I wish you were here.
I think actually she did pop into the Q&A. Greg, down below. We can return to her other question if we have time. But
okay. So spray foam headers. So basically, the rim joist or the often in basements, there's a pocket where the floor joists will end. You can see in Kevin Thomas's home, there's a joist there. You know, it's not typical because the spacing isn't 16 inches or on center. He's got like a, you know, 5 or 10 feet out. But yeah, typically that structure, that structural element, the floor joists, cut through the insulation, and they're usually poorly insulated, and they leak quite a bit of air. So it's a very vulnerable place. So insulating them and air sealing them are good. And spray foam is not the answer, but it's very convenient in a lot of cases. And I know it's not a sustainable product. It's plastic. It's made out of natural gas or whatever the feedstock is.
Okay, we had another a comment come in about heat pumps. So this person said, when you look at energy in terms of gigajoules or equivalent kilowatt hours, there's nothing in their opinion that you can do to your building envelope that will reduce your energy consumption as much as having a heat pump of any kind installed will accomplish. So how do you think, Greg, about using heat pumps versus envelope improvements, assuming somebody could only do one or the other?
Well, I think that if you were going to do only one, I would put my money down on the envelope, because the envelope is durable, it lasts a long time, and you're lowering your load. This is like paying down your mortgage. It's like putting 100 grand down on your mortgage now. You know, it'll have all the dividends in the world later on, because you can change the mechanical system later, but the envelope it's for 100 years. It's, you know, yeah, envelope.
Okay, and Jim, you want to weigh in? Jim, I'm not sure if you're speaking now, but you're just on mute.
Can you hear me now?
Yep, yeah, we can hear you now.
Can you hear me now?
Yep, you're good.
I'm just saying, I look at an ocean of energy audits that come in from various entities, REAP being one of my main people that I refer people to locally. And in every instance, when you look at the reduction in energy in a building of any kind, especially a house, there's nothing that translates to a greater energy reduction than installing a heat pump. And I just want to comment to refute one thing. Like, we've installed over 2,000 geothermal systems across the province, and I can assure you that when they're designed and installed properly, there is nothing better on the planet in terms of energy reduction, carbon reduction, peak reduction, or any metric you choose to use on the planet than geothermal. And we do air source heat pumps and geothermal, and I just look at, there's no building envelope improvement, and I don't say that improving your building envelope is not the right thing to do, because it is. But if you're talking energy reduction or carbon reduction, first of all, fossil fuels of any kind have no place in that conversation. I don't care how efficient your water heater is or your on demand. If we want to save the planet and conserve energy and reduce carbon, then there's no place in the conversation for fossil fuels, in my humble opinion.
Okay, I mean, you know, I'm not sure I agree. I would feel really sad about installing a big mechanical system for a big load, as opposed to just reducing the load. But no, it goes against all of the wisdom that I was taught over the last 20 some odd years. But
no, I'm not saying that. I'm saying the two can be done in conjunction, but to weigh one so heavily over the other is just not factual.
Well, I was asked to make a choice, and I chose to reduce my load. Sorry, do I have to jump off the diving board here? Or?
No, I'd love to have a further conversation with you, because I think there's a place for both elements in the conversation.
Well, no, there has to be. There has to be. I mean, it's unfair. I think that Garner was being a bully in the way that he, asked me that question. That's it. Like, it's all your fault.
Yeah, I'll take the hit on that one.
No, it's a good conversation. I think it's all pertinent.
No, I think we could definitely have a very long conversation about heat pumps. But
I got called to houses, big houses with geothermal systems, and it was sad, because I would call people around. I would call mechanical contractors like you, and nobody wanted to come and fix somebody else's system. They're all like, was it commissioned? What's the commissioning report? Well, client doesn't know anything about a commissioning report. Who commissions their geothermal systems? Well, I don't know. It seemed like the Wild West. And so for me, I would always, first and foremost, I wish I had your contact information, because I would have sent them your way. I'm no longer in that. I don't do energy audits anymore, or I don't do diagnostics. I test large buildings for air leakage, but I don't do those kinds of problem calls anymore. But yeah, anyways, sorry to take over the floor there.
Yeah, no problem. No, we could definitely have a long conversation about heat pumps, but in the interest of time, we'll move on. I'll also just mention to everyone, so now we're 2 minutes over. We'll go for about another 8 minutes to 9:10 if you want to stick around. And then any other questions we can answer afterwards. We can try to get emails out to people. So moving on here from the chat. I see, Greg, you're answering Dean's question. So Catherine had a question that she says that she has a double brick home built in 1914, and that she's concerned about trapping moisture in the walls and not allowing the brick walls to breathe. What's the best way to insulate these types of walls?
It's a good question, and at formerly Ryerson, now the Toronto Metropolitan University, along with RDH. RDH is another one of these companies that does quite a bit of testing of bricks to find out what they call the S-crit. So the susceptibility of bricks to fall apart and structurally lose their integrity when they're exposed to a certain amount of moisture. And yeah, it's such an important question to answer. The short and the short and the long is that if you can keep the bulk water out of your brick, so in other words, drain the rain is John Straw's, have a roof, have an overhang, make sure your troughs are working, slope your grade away from your foundation, move the water somewhere away, all your flashings, everything's working, you're draining the water. In most cases, you can successfully insulate brick on the inside without deteriorating the brick. And there's a number of caveats to that, and I would urge you to read a lot of John Stiebrick and John Straub and Joe Stiebrick's studies on this. They've covered the matter pretty extensively. Another fellow, Gonçalves, out of Montreal, an engineering firm out of Montreal. But by and large, you want to stop the air leakage from happening. So warm air carries with it moisture, and when that air goes unheated through the wall or through a window or through flashing, it eventually cools, loses its steam, and that moisture gets deposited somewhere. Next thing you know, your brick is deteriorating on the inside. So controlling air leakage and controlling vapor diffusion in your wall. So you need a vapor diffusion retarder somewhere in your assembly. Ideally the wall can dry to the outside and the inside wall can dry to the inside. Depends on where you put your vapor diffusion. But yes, by and large, you could talk to Professor Russell Richmond, who's got a double brick house like mine, same kind of thing. He insulated the heck out of his house. He's got probably R24 of spray foam on the inside, and he's in that. It's been some 15 years now, and the house is there's no signs of deterioration on the outside. So it is possible, but yeah, there's some caveats.
That's great. Okay, Matthew's asking, are there concerns or priorities for small unit buildings like duplexes and triplexes over detached homes? Maybe he's referencing any differences or priorities that would be different for duplexes and triplexes.
Yeah, I mean, by and large, the envelope for me is key here, but duplexes and triplexes, a lot of my work was also on diagnosing odor issues. So, I had one guy who lived in a condo and his neighbor would cook onions at 7 o'clock in the morning and it drove him nuts. He was drinking his coffee and he would just smell cooked onions. He's like, what the hell? And this is a brand new condo. So, we found a number of pathways that were coming through the wall, but also the heat recovery ventilators on the front porch. So the wall is here. So the apartment wall is here, and the balcony slab is here, and the pipes for the HRVs are coming right in that nook, right in there. So the intake and exhaust are right here, and so they were sucking and pulling right underneath that slab, and if the wind was in the right direction, there was it was like breathing some. It's like a Dutch oven, like pull the blanket over. Like, come on. So it's just bad design of the mechanical system, but there were also penetrations. So for sure, in multi-unit residential, I would do air tightness testing on even the shared wall assemblies. I can show you pictures of Energy Star homes here in Toronto that I've tested where during construction, the 2 layers of fireproof drywall rotted because of standing water. They tore it out and they never replaced it. So these houses are compromised. They have no fire safety in them and a ton of air moving across through that. So yeah, that would be my big thing, is just making sure that you future-proof it.
Okay, great. I'll pass it over to Tom now. I think he has a couple questions that he wanted to ask, and then we'll wrap up.
Okay.
Thanks, Gardner. Actually, I'd like to address the homeowners and just ask them a general question that we can wrap up with. So Larry, Kevin, Stephen, Neil, with regards to the, and sorry, Shaw and Katie, with regards to the retrofits you did, was there anything that surprised you after you did the retrofit? And I mean, either positively or negatively. Would you say that there was something that was even better than you thought it was going to turn out, or something that really didn't work out the way you thought and you were a little disappointed? Why don't we start over with Neil? And I know Neil's had solar panels for quite a few years. On the positive and the negative side, Neil, anything that surprised you after you did your retro?
On the negative side, it didn't produce quite as much energy as I thought it would. And then I did a little bit more research and found out that although it's rated 10 kilowatt, I expect 8. The rating doesn't always work out to be what you do. We've never had a peak of 10, ever, in the 6 years it's been installed. The thing that's turned out better on the solar has been we were in on the microfit, which is no longer available, so it's gradually getting paid off. And when it's at end of life, we'll put in a battery storage system or connect it to the house. So end of life doesn't mean end of contract life, I should say, not end of life. 20 years, we'll do something different. So that's positive.
Great, thanks, Neil. How about over to Katie and Shaw? Anything better than you expected? Anything worse than you expected after your retrofit?
Yeah, when we installed an air source heat pump for our main home, we also installed a mini split on our detached garage, which I use as a workspace. And I remember being really skeptical about, I don't know, just something about it. I didn't have high hopes that it was really gonna make it comfortable in there as a working space. And it's just been fantastic, on top of being very pleased with the heat pump for the main building as well.
Super, thanks. How about you, Stephen? I know you've got the water source heat pump, and I believe you have solar panels too, don't you?
Yeah, so on my solar panels, I was in very early, so I have, I'm only throttled at one point, so I've got quite a bit more panels than the later, than people were allowed to later. So I've been very pleased with how that's working. I mean, I think I had about a 3-year payback on my investment. On my geo system, I've been very pleased with how it worked. I've been less pleased with the original contractor that did the installation, fortunately went bankrupt and couldn't, service it. And so I've been less pleased with my ongoing service situations. But as far as heating my house, I've been very pleased with that.
All right, thanks, Stephen. And I know, Larry, you've already said a little bit about the main problem you had. Anything else to add on the positive or negative side of your geothermal?
Well, what's interesting is there's a difference in the quality of heat, because the basic heat exchange does not reach the temperature that gas furnaces do. The heat, when it comes out through the registers, is much more comfortable. It tends to cycle a bit more frequently because you don't have the high temperatures boosting the air. So there tends to be more uniform temperature throughout the day. And because of the nature of the ground source in our setup, we actually have way more air conditioning than we did before. So in summer, when it's really hot, we can just blast it without any real effort.
Okay. Thanks, Larry. Last thing, I wanted to address a question to Devin, because I know we haven't had any questions going your way, Devin. I wondered whether you had anything to add, because I know both you and Jim know a lot about heat pumps, and I just wanted to, one of the closing remarks. And I need to get back to Kevin too. Devin, did you have anything to add just briefly about heat pumps that hasn't been said tonight that you thought you might want to add?
Yeah, well, first of all, great presentation, Greg, and thank you for having me here today, Tom. I just want to sort of build on what's already been said by others, that it's really context specific what's going to work for your home. And so I like the George Box statistician quote where there's the no model is correct, but some are useful. So I like the idea of making sure that we're properly sizing systems, whether it's geo or air source. And going back to what you were saying before, Greg, and to Jim, there needs to be proper system design and installation done at the front. And so that may require some upfront additional time. And what seems to happen across North America with these systems is that people either are not doing the proper calculations correctly or they're skipping them. And so they tend to rely on rules of thumb. So you want to make sure that someone's following the appropriate steps for design, whether it's a series of calculations like a manual J, D, and S or equivalent, like here in Canada, the CSA F280 calculations to properly size the heat and cooling load and then properly select the right equipment that's going to meet your needs.
Great, thanks very much, Devin. And I did pass by Kevin when I was looking through my list of people here. Kevin, last thoughts in terms of the retrofits you've done, anything that's pleasantly surprised you or any negatives from just what you've been through?
Yeah, and we're lucky, in some ways it's a retrofit, in other ways it's almost a whole new building because what we added is about 70% larger than what was here. So in many ways we had a chance to go from scratch. And I think we really try to be future ready and anticipate where things are going. So for example, on the EV side, we realized we needed 5 EV chargers, which sounds crazy, but by the time you put one for my car, one for the wife's car, as soon as you have friends coming from Toronto, you realize you need an EV charger outside so they can plug in when they're visiting so they can get back home. And then because we've got a barn, it's not going to be long until the tractors, snow blowers, lawnmowers are all going to be EV as well. So by the time we threw 2 EV outlets out there, even though we were just roughing in the wiring, suddenly the ESA is after us saying, that's an absurd amount. You could be drawing 250 amps or whatever right there. And so there was a lot of trying to invent things and figure out that no, we weren't going to put in a commercial demand control charger, that you'd put in a apartment complex in our own house, and that I can control whether I plug in my lawnmower, tractor, and car at the same time. So the negative side is there's been too much learning where we're really inventing the path forward. That's not good. On the other side, we've figured it out, and don't underestimate the impact of all the little things. Putting that extra effort into making sure that wall assembly is extra airtight, those extra seals on the doors, the location of that window where it's just a little bit over enough to catch more sun and get more of that passive solar effect, making sure those overhangs are modeled such that the shadows are just right and you're getting that summer shading and winter sun that you need. And it's amazing when you get all those little things, how they add up to be big things. So do sweat the details. It makes a tremendous difference.
All right, great. Thanks, Kevin. So Garner, thank you. I'm going to move to the closing ceremonies now, and I do apologize to everyone for us going a little bit over tonight, but I think it was valuable to go through some of the things we went through at the end. So I'm just going to finish up by once again thanking our guest speaker tonight, our keynote speaker, Greg Labbe. Greg, thank you so much for being with us tonight. And I wanted to just let everybody know that thank you to everybody on our panel. Thank you to Garner for moderating tonight. Everybody who participated who registered tonight will be getting an email. There will be a link to a recording of this webinar. You can watch it again. I'm sure you'd love to, or you might want to pass it on to somebody else who you think might be interested. We'll send you some resources about reducing your home's energy. We'll send the contact information for our Q&A panelists. I would encourage you to send questions to our panelists. They've all indicated they're willing to answer questions. If you would like, we'll let you know which area each of the panelists is particularly or did retrofits in particular areas, so you can address your questions to the right person. We'll also give you another link to the feedback survey if you don't get a chance to fill it out tonight, when hopefully it pops up when you exit tonight. And we'll also send you some details regarding actions you can take to help the Indigenous agencies in the region of Waterloo if you are interested in doing that. Thanks again to our supporters, Kindred Credit Union, Future Ground Network, and the Township of Wilmot. And in closing, I just want to thank everybody for participating tonight. And we hope it's given you some ideas for energy efficiency retrofits. Please watch out for the next Nith Valley Eco Boosters presentation or event, which will be on community engagement. That'll be happening at the end of September. More details to come. So until then, thank you, everyone. Again, sorry we went a little over tonight, but thanks to everybody and have a good night.